Expected value is probably a more useful reason for drawing up these probability distribution tables. It's the expected gain of a random variable. It's got this symbol e of x, and it's calculated by finding the sum of the products of the probabilities and their values or their outcomes. Essentially, this will be the formula that we're using, but we'll have a look for why that's the case. We know the game Deal or No Deal, where there's all these boxes. This player here has chosen the box number 15. The hostess has the box number 11. And we know that his box either contains the number $1 or $1 million. The bank has offered him $416,000, so he can choose this amount or the amount that's in his case. So what we really want to do is calculate what he expects is in this case and then compare it to what the bank offer is. To do this, we'll look at these two outcomes. Either his case contains $1, in which case the value of the variable will be 1, or his case contains $1 million, in which case the value of the variable will be $1 million. Since there's only two cases and he's only got one case, the probability of his case containing $1 would be 1/2, and the probability of it containing $1 million would also be 1/2. So if I'm trying to calculate how much does he expect to gain, what I really know is that he's going to get $1 1/2 of the time, and he'll get $1 million half of the time. So on average, if I type this in my calculator, he's going to get 500,050 cents. The way this formula works is we're adding together all of the values multiplied by their associated probabilities. Essentially doing this multiplied plus these two multiplied. This guy's expected gain is 500,000, and the bank is only offering him $416,000, which essentially means if this player takes the bank's offer, he'll be getting less than he should expect to get if he plays the game 1,000,000 times or 1,000 times in the long run. However, he only has one chance, so depending on how much risk he likes to take, if he likes a lot of risk, sure, open up the case. On the long run, you'll do better than the bank offer, but some people might say he should take the bank offer. So if you want to have a look at this link, you can see what the outcome is. It's pretty funny seeing him talk to his family as well. We'll have a look at expected value in another game type scenario. Nikki and Melanie devise a gambling game based on tossing 3 coins simultaneously. If it's all heads or all tails, the player wins $10. Otherwise, the player loses the $5 they paid to play the game. So first of all, what's the expected gain to the player? So in my probability distribution table, I'm going to be just counting the number of heads. I'm going to define my variable as the number of heads. I can have 0, 1, 2, or 3 heads. To calculate these probabilities, I'll leave the probabilities for a second. What's the result that I'm looking at? So 3 tails. So no heads means 3 tails, in which case we're going to win $10. And for 3 heads, we'll win $10 as well. So winning is positive. In the other two scenarios, we're going to lose $5 from the player's point of view. This is all from the player's point of view. To calculate the probability of these events occurring, I'll make up my tree diagram for the 3 tosses of the coin for head and tail. I'll be able to write these probabilities. So the probability of getting 0 heads, there's 1 outcome in 8. I'll look at the number of times 1 occurs here, 1, 2, 3 times. So it'll be 3 on 8. There's 3 occurrences of 2 as well, and just the 1 occurrence of 3 heads. So from here, now that I've got my probability distribution table complete, I can look at the expected gain, or the expected value of this game. Remember, the expected value is going to be the sum of the outcomes multiplied by their associated probabilities. So I'm just working my way down this table. Multiply these two, and then add these two multiplied, and do the same thing all the way through. Put all this in my calculator. I get an expected value of negative $1.25 per game, which means the player is going to lose $1.25 each game. For part B, do Nikki and Melanie make a profit? I'd say yes, of $1.25 per game from the player. And part C, is this a fair game? No. A fair game has an expected value of 0. So a follow-on question could be, how could you make the game fair? Well, let's think about changing the price. So I could, where I see these two -5s, put this as X instead, and see how much we should charge them to play for it to be fair, to see what will get me an expected value of 0. Or I could set the winning amount to X as well. See how much we should pay out for the game to be fair. So that's the idea of expected value. It's what happens in the long run. Here's some questions for you to have a go at. Good luck.